Hey, thanks for joining us once again here on Construction Tech Talk for another of our We Talk to Smart People episodes where we're joined again by Yaron Dycian of Wint. How's your day going, sir?
It's going really well. Had a great time this day.
So I've been following Wint for quite a while here because they've got an IoT edge computing AI application. And we've got two sexy things there. We've got IoT, which we're going to talk a lot about here. But first, let's talk about the AI component on this, Yaron. It seems like everyone in the world is talking about AI now, and we're trying to, on Iron Pros, help folks understand the difference between AI is supposed to try to emulate a human being, which, for the life of me, I can't figure that out. I've been an idiot my whole life. I wouldn't want to pay for a device to do what I do. But in terms of what you're doing there at Wint, what are some things that you have been able to achieve by marrying AI and IoT in this situation?
Yeah. So, AI is a big word, right? It's almost like saying computing these days. As you mentioned, AI that can emulate a human being and converse with them, ChatGPT is one thing. The AI that we do uses the same statistical and computational logic, but it does a very different thing altogether. And by the way, we don't need a server farm. ChatGPT, this is like it uses a state level amount of electricity. So AI is a big word. For us, AI is understanding what is normal for a water flow at a specific location. Smaller problem than emulating a human being. I'll be the first to admit that. But it's a complex problem, right? You look at some water flows and you try to figure out, is this good or bad? Is this legit or not? Should I shut off a valve or not? Am I going to disrupt the whole building? Am I going to disrupt the construction project? Or am I, saving the building by, eliminating a huge flood that could cost tens of millions? So that's what we're about. When you get into these things, you first of all need to look at a lot of data. All of these AI things are all based on significant analysis of data. I think at this point in our life, we've been around for 10 years or so, and we have seen water flow patterns. I mean, for here and from here to eternity, we've got probably millions of hours of water flow data, and that's how AI starts. And then you need to build the algorithms that figure out, how from all this data can I figure out what's good and what's bad. And that's the essence of Wint. The rest is a lot of hard work, but that's the core. That's the soul of it.
Yeah, well, with Wint standing for, as I recall, water intelligence, uh, what type of pattern or program of work did you have to go through to educate this AI to sense water leaks? Why don't you just kind of give us a quick history?
Yeah, so we started small. We started actually in apartments or single family homes, and the water flow there is very simple. But you start getting the grasp of it. You understand how things work, and you build the algorithms, and you start training them on that. And then you install in a commercial building, and it looks very different, but you have a head start. So it takes a couple more years, learning and understanding commercial facilities and how they behave and how that relates to the really simple home level application. And then you've got the additional layer. Construction projects are crazy from a water use perspective, right? Because 3 weeks nothing happens, and then the next week they're starting to do some big works, and it's just up and down. And people keep telling us there's no way you'll find sense and order in this thing, but there is actually. So the data science problem, you start small and you grow bigger and bigger and bigger. And I don't know if we could ever, had we started in construction, if we be good at it, but that gradual evolution has really helped us.
So if you're looking at, the different stages of creating an AI application like this, what apart from like starting small and going bigger, did you have to do some substantial work to begin with to define the problem and help this application understand what conditions are to be identified and remediated?
Yeah. Well, the funny thing about AI is you don't tell the system what to look for.
Yeah.
You kind of tell it, here are some good examples and bad examples, and here are the attributes that you should be looking at, but I'm not going to tell you, you figure it out. And you actually train it by example. You do two things. You tell it what kind of characteristics of the water flow pattern to look at. And then you give it a lot of these attributes and you tell them those are good and those are bad. And now you tell me if this one's good and bad. So it's a very different way. Programming used to be, here's the rule. If I have a flow of over 20 liters per hour or 50 gallons per minute or whatever, right? For over 10 minutes, that's good or bad. That's how it used to be. It's too the world is too complicated for this to work. It works in some cases, but not, for example, in water flow. And so in AI, you don't do that. You tell it, you look at this, this, and this, water flow rate being one of them, and other attributes are also very important. Now, here are all the attributes as they look right now, and you tell me if now is good or bad. So it's a totally different way of thinking about computing. That's why AI is mind-boggling to so many people, including me, and I've been at this for a while.
Yeah, yeah. Well, there's the AI element of the Wint solution, and then there's the IoT element of it. The fact that you are gathering information, from the physical environment. That's the IoT side of it, and the AI side is figuring out, well, what does this mean for the decision whether or not to shut on or off a valve or send a notification to someone. Uh, what's the trick to getting the AI and the IoT to combine together in a productive product? Because it seems to me like we would likely be seeing a lot more of this coming to market soon.
Yeah, well, probably, but it's not an easy feat. So, first of all, you need to get your algorithms right, and that means you need a very high probability of detection for a real event. I mean, if I miss a leak in your construction site 5 days before handover, and you've got all these expensive floorings and whatnot, you're not going to be happy. Even if it's only 1 out of 100, I've got many more than 100 customers. If I get that, I'm going to be in trouble. So your true detection ratio, that's the professional term, needs to be very, very high. But on the flip side, you can't over alert. I cannot send you alerts all day in and out because you'll start to get annoyed. And when the real one comes along, you'll ignore it because you're used to everything being false. So that false ratio to true detection kind of relationship is very important. Then you need to start to think about more, down to earth things. For example, I'm running on the construction site, and we know construction sites are not finished buildings. They don't have proper communication at all times. They don't have power at all times, and you still need to provide the protection. So you need to build your device in a way that has battery backup and in a way that has maybe multiple communication methods, and in any case can protect you when you don't have communication. Because what if the cell tower is down? What if the cell tower is far away? What if the cable got cut because somebody ran over it? It's a construction site. So you need to still provide protection. So these are some of the more down to earth but very important things to do. And a lot of these things, I'll tell you, it's hard to think about everything up front. You really try. But then again, life teaches you that you missed something and you were wrong on something else. So experience really plays. I mean, right, we know what it is like. You can't become an excellent GC on your first project and bring in people without experience. It's just, you learn from experience and you improve with experience.
Yeah. So right now you have product in the market, you've got partnerships and integrations, and you've got advantageous arrangements with insurance companies to incent contractors and facilities managers from really opting for this technology. What is next for Wint? And if there are other products or developments or academic research that speak to the future of this IoT AI combination in construction, yeah, hit me with it.
All right. So I'll hit you with two different things. One is more, how do you get to really so here are the problems we're dealing with. We're dealing with a lot of damage and losses on buildings and on construction sites, and we're dealing with a huge worldwide environmental problem. right? The world's drying up, the world's heating up, and they're kind of contributing, right? You're heating up, therefore you're drying up. You're drying up because you're using too much water. You're using water, that generates carbon emissions. So this is a vicious cycle. So these are two mega problems. To us, the first challenge that we want to actually nail is make sure that this kind of solution, obviously we want us, but in general, this kind of solution becomes ubiquitous. And people don't have a doubt that this is something that helps the environment and helps them on the commercial side. So that's our number one goal is to become this, to turn this into a much more standard thing. So buildings are built with water management solutions as a core part of the building. It's part of the fabric. You manage water. Think of it. Up until now, water's been a totally unmanaged asset in the building. It goes in through a pipe and you open a tap. That's as much management as you give this thing. And it's an important asset and it's a damaging asset. So water management in buildings, in our vision, will be a standard thing, I don't know, 5, 10 years from now. I don't know, something like that. Now, you also asked about our vision, our technological vision. So we've developed technology that is very good at analyzing anomalies on things that flow over time, right? Water flows over time.
Yeah.
But many other things flow over time. For example, temperature. You can think of temperature as a time flow, right? It goes up and down. And essentially, if I showed you both charts, they'd look about the same. So there's a lot more that can be done using this technology to analyze things in buildings and in manufacturing facilities and make them better. I'll give you an example. Your HVAC system in the building, it has its own behavior. It has its energy usage flow chart. So over time, you'll see how much energy and how that changes for your HVAC system. And I can do analysis on this and tell you that on the 4th floor, somebody probably left a window open and it's eating up too much energy. So, here you go. You have an indication for a new thing. And we're going to add more and more data points and parameters to measure to make this a much bigger solution.
Okay. Well, you spilled the beans there, and I appreciate that. Give us something a little bit interesting, and something else we can look forward to hearing more about. So, if you like hearing about the future of these disruptive technologies in the construction space, keep on coming back here to Iron Pros, and we'll try to get Yaron back on here very soon.
Thanks, Chuck. Had a great time.
Yeah, talk soon.